Hey, how's it, YouTube? This is another Sega Saturn eBay rescue. Today we have a Model 1 Sega Saturn, but this is an early first revision Model 1, and you can tell because of the power supply here. You can see it's an unnotched plug, and you can see the whole shape is different. Condition wise, this is not bad. Light scratches here and there. I think it'll buff out using the magic erase method, which one of the subscribers recommended, with free shipping. All in all, the condition's not bad. Let's take a look inside. The lid here, unlike a recent previous repair, there's no damage to the tray here or the spindle, and the laser looks intact. And price was $29.98. What the seller described as the problem was the power light was blinking, and also there was strange noises coming from the inside. Without further ado, let's get to troubleshooting.
You're watching the Sega Holic.
Okay, we have the Saturn here hooked up, and I already tested out all the cables to make sure they were working. And you can see the power light blinking and the Saturn making a slight ticking noise. No video, so I think that's one of the symptoms with the blinking power light. For this early Model 1, you will get no video until this is fixed. First off, I'm gonna clean off the exterior of the Saturn. This is 99% isopropyl alcohol. It leaves behind no residue. You really want something that leaves behind zero residue for your laser lenses. And the particular thing with isopropyl alcohol is it's plastic safe. I was able to source this from Fry's Electronics. Try not to rub on the power or access wording here, as the wording can actually rub off. You can see this particular Saturn has the all rubber foot, not the felt ones with the plastic sheet over the top. The internals of this Sega Saturn is a bit different from all the other Saturns because we have components mounted at the top cover. So what you want to do is lift up the back side of the cover, and this is going to be my first time doing this in a while. So we have the power board here. Looks like we can take off this plug right here, and we have another wire going to the main board, so we can carefully pull this out. Here's another wire with looks like an RFI magnet. Pull this out here. This wire is actually being held down by this here, so with this we can slightly open up to release the wire, which is wrapped around, and we can remove this wire that's going to the CD board. And then we have one last wire. Looks like this is going to the reset button, and we can go ahead and pull that out. The only connector with a tab to release is this one right here, the power board connector. You just press on here to release it. All the other ones you just carefully wiggle and pull out. Okay, looks like this Saturn hasn't been opened before. You can sort of kind of tell because there's a thin layer of dust in here. All of the original tape is still here, and it really looks like it hasn't been opened at all. So comparing this to what we've seen with the 64 and 32 pin Saturns, as well as the late Model 1, looks very similar, except for the power board being in the top case here. And also the CD assembly looks very similar. And these should use the same laser pickup as all the other Saturns, barring the late Model 2, which is the one with the trap here. Another major difference would be the ribbon cable that connects the main board to the CD board. Looks like this is horizontal now. It runs vertically, going from the power board up to the CD board, instead of from here horizontally to here. Okay, here's a detailed look at the upper cover, which again has a whole bunch of stuff mounted to it. First we have the door switch here. You can see here it's a really small switch, and the wire to it was actually this one with the RFI magnet that goes to, I believe it was the CD board. And here we have the reset PCB, which contains an LED for the light, and also what would be, I would guess, is a surface mounted switch right on the back side. And here we have the power LED, which has its own board, power switch here, instead of again being mounted to the bottom chassis, and obviously the power board here. With the cover off and the power supply disconnected from the main board, the power switch and power supply are isolated, so we can simply plug in the power cord into the power supply. Be careful in handling the top cover now because of the exposed electronics here. Keep your hands away from the electronics. From here we can turn on the power supply, and you can hear a slight ticking noise. So it looks like the problem is the power supply. We're gonna have to remove the power supply and do an inspection. For the power supply, there are 3 screws. The one here uses a number 1 screwdriver, and these 2 back ones uses a number 2. And you can take this connector off for the power switch. Okay, you can see here my new anti-static mat, which I just got from eBay. I'm not home right now, so I don't have all my usual stuff. I googled for power supply issues related to ticking or just power supply repair. Most of the issues that's on the internet right now related to power supply repair, specifically switching power supplies for electronic devices, the issue has been bad capacitors. What I'm gonna do, even though they don't look damaged in any way, you don't have like the really protruding top, I'm gonna replace these capacitors and hopefully they work. What I haven't been able to find is anything wrong with any of these components physically. Since I don't have any type of schematics for this power supply nor any type of proper testing equipment, I'll just go ahead with the notion that these capacitors are bad and we'll just hope for the best. One thing to note about power supply repair is be very careful with these. If you don't know what you're doing or have little experience with electronics, I would just replace this whole power supply. So if you don't have any experience, again, do not try to repair a power supply. It could be a fire hazard and could be very hazardous. I was also able to score this solder sucker or desoldering iron for $5 out here in Phoenix from Circuit Specialist. This is again only $5 or $6 for a 40-watt desoldering iron. This is different from my other bulb type desoldering iron, as this one has a pump. It is pushed down on the pump here. This works like a syringe, and once you get this on the solder joint, press this button here and this creates a sucking action right at the tip. Before you pull the caps off, make sure you label where the caps go for your replacements. In this case, you can see this cap right here is labeled C12 right on the board. This cap right here is labeled C50. So on a scratch piece of paper, just write down the values of each capacitor to make sure you get the right capacitor in each location. Again, this is my first time using this type of soldering iron or desoldering iron, and that looks pretty good. This is a pretty awesome tool. Considering I only paid $5 or $6 for this, this is a pretty awesome deal. When you're done desoldering with the soldering iron, this is easy to clean. You push down here and then pull slightly forward, and this mechanism comes apart. You can see here all the solder that was sucked up. And when you clean this also, just re-lubricate this O-ring right here so you don't lose sucking power. And the other great thing about this desoldering iron is these tips here. These replacement tips are only 99 cents each. So this is a very economical desoldering iron, very easy to use and highly recommended. Fry's Electronics. This used to be a dork's dream come true, but now we have a lot of online stores, so these brick and mortars are slowly shutting down. Before we solder, the replacement capacitors on. Just want to clean off the pads with some isopropyl alcohol. Here's a closer look at one of the removed capacitors. Here, this capacitor is a 10 volt 4700 microfarad capacitor. This U symbol here actually stands for micro. You also notice the negative labeling here, which denotes this is the cathode side and the positive side is the anode side. Again, this micro here is one of the common denominations for fractions in electronics. Again, this is millionths. You also might hear of the term milli, which is thousandths, and also nano, which is billionths. Here's a look at the board with the capacitors removed. Most of the time, the boards will be labeled. These lines here that go right across the circles where the capacitors were sitting denotes the cathode side of the capacitor, while the anode side is actually labeled with pluses, and you can see them right there. They're really small pluses. So when you do replace your capacitors on the board, make sure you have them the correct way. Here are the replacement capacitors that I ordered from Mauser, which came in a few days ago. You can see here the replacement capacitors are exactly the same size as their removed counterparts, except for the big one right here, the 200 volt 120 microfarad capacitor. This is a Marom brand capacitor. The replacements are all Nichicon, but for this particular one, the 120 microfarad 200 volt capacitor was not available in the series I was looking for. This is a CY series, but luckily the leg spacing are the same, so this will fit directly in the hole. The rest of the capacitors are exactly the same size. It's because Nichicon actually acquired the Toa brand, and you can see here they're exactly the same size. For the rest of the capacitors here that I used was the PW series from Nichicon, which are made for switching power supplies, which this is. Again, this is a switching power supply from the Saturn. I scored this variable temperature soldering iron from Computer Specialist out here in Tempe, Arizona for $17.99. This was an open box and was quite a steal. Again, this one is an ESD safe soldering iron. These are Chinese knockoffs of the Hakko brand. First, we're gonna put on the 16 volt 47 microfarad capacitor, and we'll just shape the legs like the old one. And we're gonna turn on the soldering iron to 700 degrees. Now we're gonna apply some flux to the area we're gonna solder. And again, we're using 6040 solder. This is the leaded type. And then we're gonna use some newly acquired Hakko brand snips to cut off the legs. Just gonna use some tape to hold on the capacitor while I solder it into place. When you solder, all your joints should be shiny. That way you know you don't have a cold joint. Okay, this looks good. And so here it goes. Notice here the power light is still blinking. I'm at my wit's end now. Arrgh!